Okay, we're going to be again on page 16 today. The sort of second part of this unit is going to focus a lot on graphs. So we've seen graphs already. The first intro problem that we're going to look at today has sort of a refresher of what we've used graphs so far. But the first part of our unit, we had a lot of focus on input, output, and function notation. And again, we did see graphs as part of that. But moving forward for the rest of this week into next week, we're really going to be focused on features of graphs. Okay, so really focusing on what we can do with our graphs here. So if we take a look at the top of page 16, this is an example of how we've used graphs so far. So this is Emma's walking home from school at a constant rate. This graph represents function d, which gives her distance from home in kilometers, m minutes since leaving the school. So here's the time that she's been walking home. Here's her distance from her house. Does this graph make sense? Like she starts off far from her house. As time passes, she's getting closer to her house. Yeah, because she's walking home, right? So I would expect as she walks, the distance to her house should get shorter, right? The longer she walks home, the closer she gets to her house, the less she has still to walk. So this is what we've done with graphs so far in this unit. We've used sort of our function notation to be able to evaluate. Remember that number in parentheses is our x value. So for these first two, we're given an x value. We're trying to find its y. So d of 0 means our x value is 0. We want to know what would be the y that corresponds with that. So what's our y value for this point? Yeah, about 2.25. There's going to be some estimating today. That's okay. D of 12 means our x value is 12. Find that point on the graph and then estimate the y. So if we had to estimate our y here, yeah, it's like just under 1.9 is a good estimate. And then for 3 and 4, this should be d of m. For 3 and 4, we don't know that x value, but we do know the y. So we'll reverse this. We'll use the y to figure out what that x is supposed to be. So for this first one, or I should say for number 3, we know our y value is 1. If we follow that to our graph, we want to know what's the x value that corresponds with that. So about what would be our x value here? 11, sure. And then when our y value is 0, that'd be down here. Follow that to my graph. What's my x value? 20. So this is primarily how we've used graphs so far in this unit. Again, today we're going to talk more about specific features of graphs and what we're seeing here. So for number 1, it says we have a toy rocket and a drone that were launched at the same time. Here are the graphs that represent the heights of the two objects as a function of time since they were launched. So we've got our rocket here, our rocket graph here, and then this is our drone. And we're going to actually start from the bottom. We're going to start with the stuff that's familiar. So x-intercepts, we've seen x-intercepts before. If we look at our rocket graph, where do I have an x-intercept? At 5. Remember, x-intercepts are where we cross or touch the x-axis. We have an x-intercept here at 5. How about a y-intercept? Yeah, right here, where I touch across the y-axis, which looks like it's at about 25. How about a maximum? So what am I looking for when I look for a maximum on the graph? What was that? Yeah, an x and y value that's the highest point on the graph, right? So the idea behind a maximum is I've got like the top of a mountain, right? I've got some sort of peak that's the highest point. So we have that here, and it looks like it's about 2,45. Does that seem reasonable? Okay, so we have a maximum at 2,45. And then here's the part that we haven't really talked about yet. I know you guys have seen x and y intercepts and minimums and maximums. We talked a lot about x and y intercepts in here. We've seen minimums and maximums before, and I know you've seen them before this class. So what we're going to take a look at next is going to be something we call increasing and decreasing intervals. And then we're also going to take a look at positive and negative intervals today. So here's the big idea. When I read a graph, I read it from left to right, the same way I read words on a page. Okay, we read a graph just like we read a sentence. When a graph is increasing, let's actually take the graph out of the context for a second. If I told you something is increasing, what would that mean? It's going up, right? If I told you something is decreasing, that means it's going down. It means the same thing on a graph. So as I read my graph from left to right, if my function is increasing, that means I'm going up from left to right. If it's decreasing, that means it's going down from left to right. So as I look at my graph here, okay, I'm going to start at the edge of my graph. And as I sort of trace this, see how my pen is going up across the page? Up is increasing, right? Something's going up, that means it's increasing. The sort of new part here is how we're going to describe this interval. You guys know what it means to be increasing, but the new part is how we describe that a section of a graph is increasing. So when I write an interval for a graph, I name it based on the x value where it starts, and then the x value where it stops. We name it based on the x values because the x-axis is the one that goes left to right. So remember, we read a graph from left to right. So I'm talking about my graph is going up as I go from left to right. The x-axis is the one that gives me a frame of reference for when this starts and when it stops. So that's why we use the x-axis here. So we have an increasing interval from when x is 0 until x is 2. So we have an increasing interval from 0 to 2. Does that make sense? Okay. Since the x-axis is the one that goes from left to right, we use it as our gauge. Decreasing, we said, means we're going down. So the maximum here is sort of my turning point, right? That's where I'm switching what I'm doing. So after the maximum, now we're going down. Now we're decreasing. And we're decreasing from 2 until 5. So my decreasing interval is 2, 5. Now, I do want to point out these intervals are named based on what the y values are doing. So we describe them based on x values. But what we see here on our increasing interval is that the y values are the ones that are increasing. On our decreasing interval, it's the y values that are decreasing as we continue along our graph. We're going to talk about positive and negative intervals in a couple of minutes, and those are again named based on what the y value is doing. So positive intervals are where the y value is positive. Negative intervals are where the y value, so the y coordinates for those points on that section of the graph are going to be negative. So yeah, we want to name our intervals with most of what we're going to see as parentheses. It is also possible to name our name our intervals with brackets on the end. I actually could have used a bracket here at 0 because this is not a point of transition. Does that make sense? Like here, I'm switching from one thing to the next. So I want to use a parenthesis. I also could have used a bracket down here too, because this is not a point of transition. It's just the end. Does that make sense? Okay. That was a good question. Okay, other questions about our rocket graph. Let's take a look at our drone now. I want you guys to find your x and y intercepts for our drone. Find the x and y intercepts for the drone. What do we see here for x intercepts? X intercepts here. Yeah, we've got 2, 0, and 7. Y-intercepts? Yeah, this point right here kind of does double duty, right? It's an x-intercept and a y-intercept. So y-intercept at 0. Now, how about a maximum for this graph? So that's the maximum y value. So if I asked you, yeah, we're getting those 20s again. If I asked you what's the maximum height that the drone reached, 20 meters, right? Because that's the highest height that it gets to. But remember when we talk about minimums and maximums on a graph, our technical definition there, our mathematical definition, is that a maximum is the highest point for its location. So all of the other points surrounding this point are lower. Does that make sense? So if I look here, all of the points surrounding this are lower. Some of them are fairly lower, but they're lower. If I pick a point, I heard 220, or if I pick up any point up here on this plateau, are all of the surrounding points lower? No, not even on the corner. These ones are lower, but these ones are all the same height, right? So according to our sort of graphical definition, do I have a maximum for this graph? I actually don't. So in the context of my problem, does my drone reach a maximum height? Yeah, it does. It gets to a maximum height of 20, but do I have a maximum on my graph? No, that's where our sort of mathematical world and our in context world are going to differ a little bit. So I'm going to write none for a maximum here. And then let's talk increasing and decreasing intervals. Let me get my highlighters back out here. So increasing, remember that's as I read my graph from left to right, I'm going up. So if I were to trace it with my pencil, I'd be going up across the page. And as I sort of start tracing my graph, that's what I'm doing. From here to here, I'm going up. So that interval is from 0 to 2, right? Those are the x values that span that section of the graph. So from 0 to 2. And I could, again, like we talked about before, use a bracket here. But then from 2 to 5 is not increasing or decreasing. Is that fair to say? Right? We're constant right there. We have that plateau. So that's not increasing or decreasing. But I do start decreasing for the section of my graph where my drone is coming back down to the ground. That would be right here. So from 5 to 7. And as we talked about before, I could use a bracket on the end. So I'm not going to be super picky about brackets versus parentheses for right now. Just I'm using and sort of pointing out when I'm using one or the other, just to sort of introduce us to that idea. Questions for me so far? Okay, now let's talk a little bit about positive and negative intervals. So a positive interval is any section of the graph where the y values are positive. And a negative interval is any section of the graph where the y values are negative. A little bit easier way to think about this is it above or below the x-axis? So everything that we've got right here is above the x-axis. Does that make sense? So all of these pieces of both graphs are all positive because they're all above the x-axis. A negative interval would be something that's stretched down below the x-axis. Does that make sense? If I had chunks of my graph down here. So these would be pieces of the graph that would be negative. Those would be negative intervals. Okay. In the context of this problem, why would I not extend my graph down and have pieces that were negative intervals? Yeah, so a 0 height here is going to mean we're at ground level. So if I were to continue my graph down here, that means that my rocket went up in the air, came down, and then like burrowed into the ground. That might be cool, but it's probably not what we're actually going to see here. Or like my drone lands and then like a little shovel pops out and it starts like digging a hole down into the ground. Not what we're going to see here. So that's why we don't have any negative intervals as part of this graph. Questions for me so far? Okay, turn to the next page for me. And we're going to look at another example. On the next page, our graph represents the sort of trajectory of a bungee jumper. Has anyone been bungee jumping? You have? So correct me if I'm wrong, but I believe it goes something like this. You stand on a platform, like above a canyon or over a river or something. When my husband did it, I think they were over a river. Somebody basically ties a giant rubber band to your legs. It's like legit, you get strapped in. Then you jump off and you fall down. You don't like jump, fall. Yeah. You fall down and the first sort of fall is as low as you're ever going to go. Then you spring back up and you don't spring up all the way. And then you fall down again, but not as low as the first time. And then you come back up, but not as high as the first time that you bounced up. And you kind of bounce up and down for a little bit until eventually you're just dangling there. And then usually they crank you back up. Yeah. Yeah. Okay. So that's what we see here, right? Here's our platform. There's our first fall. There's our first bounce back up. Then we fall, but not as low as the first time. Then we pop back up, but not as high. And then we fall, and then we kind of bounce back up and down there for a little bit until eventually we're just going to be maybe swinging around at about the same height, okay? Until our momentum's all spent and we stop moving. So for our graph here, let's start by looking at our increasing intervals. Remember, increasing means as we read our graph from left to right, we're going up across the page. So I fall off the platform. I'm not going up. Fair to say? Okay. Here is where I reach the bottom of that first fall down. And then I spring back up, right? So my height increases over that time. So our graph is increasing over that section. And then here we're decreasing again. And then we increase again. That's not increasing, but this section is. That's not increasing, but then this last section is. So they're all of our increasing pieces of our graph. Let's name two of them. We're going to give interval descriptions for two of them. Okay. 14, 17. So are you describing this interval here? Yeah. And then let's name our last interval here. Where do I start increasing? At 33? Sure. 33 is a good estimate. Where do I stop increasing? At 30, this would be 35, right? Now let's talk about some decreasing intervals. So my first section here, I am decreasing. And then we have that increasing piece, and then we're decreasing. Essentially, I'm looking at all the parts that I skipped over last time. I would like you please to describe this first decreasing interval for me. Where do I start decreasing for this interval? At 0. And where do I stop decreasing? But like right before 5, so 4, 4.5, something in there is good. And then how about this section? Where do I start decreasing? So it's going to be where this one left off, right? Because you guys described this one to me. So if this one left off at 17, that was my transition point. It's got to pick up at that same spot. Does that make sense? So this would be 17, comma, and then where do I stop? 24 sounds good. What's the y-intercept for this graph? Right here, right? It's above 70. It's not to 80. Low to mid 70s somewhere. I heard 75, I thought. 75 works. One of my earlier classes said 73. That's good too. long as your estimate is reasonable. And then we're going to skip talking about end behavior for today. We'll come back to this topic a little bit later, but for today, I want to focus a little more on those intervals. And then I want to talk about classifying minimums and maximums. We talked about maximums with our last problem. But there, in a graph like this where I've got multiple minimums and maximums, there's a further way that I could talk about these points. And that's to classify the type of minimum or maximum that I have. So relative or local maximums or minimums, and then absolute or global maximums or minimums. Relative and local are interchangeable for our purposes. And then global and absolute, again, interchangeable. They mean the same thing. What would be a global maximum? When I talk about global maximum, that's the highest point on the entire graph. When I talk about a global minimum, that's going to be the lowest point on the entire graph. There is no point anywhere else on this graph that is higher or lower than that global point. Okay, so global is the highest or lowest, if we're talking minimum, highest or lowest point on the graph. Nothing is higher or lower than this point. So if I pop up to my graph here, do I have a global maximum? Where? At 0,75, right? At that y-intercept. That's our highest point on the entire graph. That's a global maximum. Do I have a global minimum? Do I have a lowest point? Yeah, this guy right here. Okay, that's the lowest point on our entire graph. So that's a global minimum. Now, not every graph is going to have global minimums or maximums, even if it has minimums or maximums. This particular graph has both. That doesn't mean every graph will have one or the other or both. So global is the highest point or lowest point on the entire graph. What about local? What about a local minimum or maximum?
Highest or lowest point within a certain section?
Yeah, it's a high point or a low point for the area, but not the highest or lowest for the entire graph. Check Google Classroom. Okay, highest or low point for the area. It's a high or low point for the area, but not the highest or lowest on the graph. So if I pop back up to my graph here, local maximum, local maximum, local maximum, local maximum, local minimum, local minimum, local minimum. Does that difference make sense? Okay. Turn the page for me. And the last thing I want you to do is take a look at the graph on page 18. I want you guys to give this one a try. So you know how to find x and y intercepts, maximums and minimums. And then I would also like you to try identifying our positive and negative, as well as our increasing and decreasing intervals. So you guys give these a try, and then we'll talk about them together in a couple minutes. Just as a reminder, positive sections of the graph are above the x-axis. Negative sections of the graph are below the x-axis. Okay, so use your graph on page 18 and identify those key features. Okay, let's talk about our intercepts here. Where do I have x-intercepts? One. Gotta label these as my x-intercepts at 1, at 7, and at 3. Any y-intercepts? At -1, I have a y-intercept. Now let's talk maximums and minimums. Any maximums on this graph? We got a maximum at 2, 1. Any other maximums on this graph? Yeah, this guy right here. So that was -5, -2. Anything else? 0, 7, or 7, 0. That would be 7, 0. Also a maximum. Now let's classify these as a local or global. 2, 1, this point right here, local or global maximum? Global, that's the highest point on the entire graph. Global. How about -5, -2? Local. And 7, 0? Also local. What about minimums? Minimums. -3, -4, that guy right there. Any other minimums? -2, switch that, 5, -2. And then let's classify these. Local or global? Global. Local or global? Local. Okay, now let's take a look at some of these intervals. Let's actually start with increasing and decreasing. Since we've done a couple examples of that, let's start there. So increasing, remember, as we read our graph from left to right, I'm looking at where I'm going up. So I have an increasing section here. So I'm going up. Where does my increasing section start? -3, and it goes until 2. And then that's not increasing, but this last section is. So this starts at 5 and goes until 5 to 7. And now let's do decreasing. So there's a decreasing section of my graph. 1, 2, 3, 4, 5. It starts at -5 and goes until -3. So from -5 to -3. And then here's another decreasing section. What would that interval be? 2 to 5. And now let's talk positive and negative. Remember, positive is where I'm above the x-axis. So the positive section of this graph would be this part right here. That's the positive interval for this graph. So we name them the same way. It starts at 1 and ends at 3. Does that make sense? Positive interval from 1 to 3. And that's actually the only section of this graph that's above the x-axis. So that's the only positive section of this graph. Here, I have a negative section of my graph because that's all below the x-axis. Okay, this part here. It starts at -5 and it goes until 1. So I have a negative interval from -5 until 1. another color so we can read that a little easier. So from -5 until 1. And then I have another negative section of my graph. What would this interval be? 3 to 7. Very good. And again, I'll write this in a color that we can see. Questions for me for today? Okay. Your homework for tonight is 2 Khan Academy assignments, and you do have some time in class. You can get those at least started before you leave today. 2 Khan Academy assignments. One is over increasing and decreasing intervals, and the other is over positive and negative intervals. Again, using graphs just like we did today, okay? I know you guys can find X and Y intercepts. I know you know what minimums and maximums are, so your homework is just gonna focus on those new ideas, those increasing, decreasing intervals, and the positive and negative intervals.